This is a longish answer, though.
Oh, you're right.
So I took a whole page to do it, but here is the question. It was on last year's exam. So what is LTP? And so I just, this is the thing that I gave for the TAs to grade with, and I just downloaded this and put it right from the textbook. Long-term potentiation of the dentate granule cell synapse. I didn't ask you to draw this picture, but you know, this picture helps you to think about it. So here's LTP. This is the hippocampus of the rat or the rabbit. They all look kind of like this, the dorsal hippocampus. And LTP is stimulating this pathway of fibers that goes, these are neurons that go into the hippocampus and make synaptic contacts on the granule cell layer in CA1 to CA3 of the hippocampus. And if you stimulate in the input pathway and record extracellular neural activity in the granule cell layer with a small pipette, you can pick up the population of the neurons in this area, and they're not really big ones like this, they're much smaller, but and this is a cartoon. There'd be several hundred near that tip, and you look at the response of quite a few of them, and here's the blip caused by stimulation the very first time. It gives a little population spike and then kind of an after effect, and this is, if it's done once very intensely, later on the responses are bigger. If you stimulate to start with and then stimulate right after again, about an hour later you're getting a population spike that's different from the initial. So that initially that dip went down here and then up a little bit. An hour later that dip's going way down and then it's going higher there and lower there. And 2 days it's even greater than it was after 1 hour. And 4 days and a month later you could still be getting this potentiated activity based on the fact that you stimulated once here very intensely and stimulated right after it again. So you get these things activated and then you hit it again right after. And this is the population spike on trial 1 of stimulation. And then an hour later you get a much bigger effect, and this persists basically as long as you can record from this record. So that's potentiation of the inputs from stimulating these neurons into, and we're actually measuring them on their target neurons, the target cells here, these dentate granule cell neurons. Okay, so that's helpful. So that's the figure, but oops, here's my answer. And I'll make this as big as I can. Working out. So guys, can you read this? I'll read it to you. Long-term potentiation is LTP is acronym for long-term potentiation or facilitation of synaptic transmission following high-frequency electrical stimulation applied to the presynaptic neurons that activate the synapse. So those preferred inputs. And in the LTP experiment, a brief period of intense high-frequency stimulation enhances the subsequent response of postsynaptic neurons to low-intensity stimulation of the presynaptic neurons. So you stimulate them with low intensity, then high intensity right after, bingo, the next time they're just like, wow, that was good. So you could think that was good, that's LTP. That sort of woke them up and they know something's coming. Actually, that's a really good way of putting it, and I never thought of it. You wake them up and then you hit them again, and they really take notice. They take notice like they've never taken notice before, and from now on, remind me if I miss this next time I'm teaching. This is a good way of thinking about it.
It's documented.
Well, I just thought of this as I'm talking about it. Sometimes you just think of things on the spot. But this is a good way of thinking about it. So subsequent response is going to be pretty high. This enhancement can last for weeks, months, depending on the number, duration, frequency, and intensity of inducing stimulation. For basically saying that, or a version of that, we gave you 3 points. Okay? And, this is my answer, and we don't expect any of you to come up with, I've been doing this for a few days. And I put it together from what was in the textbook plus what I know, and most of you who got really good grades probably got about 80% of that, or basically hit the high points anyway. So LTP is interesting because it's a kind of change that was postulated by Donald Head in 1949 to underlie this memory. He said there's some facilitation of a neural synapses going on. He called it a reverberating circuit. And this is the clearest experimental evidence. This isn't just hypothesizing. They stimulated, they recorded, and next time they recorded with the same stimulation, it wasn't the same as the first time. So, and you do it a few hours later, and it's not the same. It's already taken a permanent change. These guys didn't really figure it out. This Lomo guy could have been famous even before Goddard, McIntyre, and Leach discovered kindling. He could have had the kind of, this is the most impressive. He actually had electrophysiological evidence. He recorded that population spike was different. Goddard, McIntyre, and Leach just discovered that you keep on activating, and pretty soon the animal's behavior changes. And it's a form of enduring change too. So, but this was the first really clear experimental evidence of enduring change in synaptic transmission that Donald Head had postulated. He suggested this was the basis of long-term memory. So LTP has 2 qualities that fit the type of synaptic change that Head suggested would underlie learning. It's reasonably permanent, and it occurs when both the pre- and postsynaptic neurons are simultaneously active. So he gives them that low first stimulation and then hits them after, and they've had a wake-up call plus the knock-out, the really big excitement, and they're never going to be the same. So it's occurring with both pre- and postsynaptic simultaneously activity. This co-occurrence of activation is called Head's, or this need for co-occurrence is called Head's postulate for learning. So much effort has focused on using this type of preparation to study the neural basis of learning. Well, that's another 3 points, so you're up to 6 points now. You need another 4 points. And the question asked, I think I just messed up here. Get this to drag very well. Delayed some